अभी अभी दिख रहा है, एक बार कंफर्म कर दीजिए प्लीज। ओके। तो कॉलम्स में लॉन्ग कॉलम्स होता है और शॉर्ट कॉलम्स होता है। तो टू टाइप्स ऑफ कॉलम्स। तो अगर शॉर्ट कॉलम्स, इन केस ऑफ शॉर्ट कॉलम्स, दिस इज द कॉलम। तो अगर लोड अप्लाई करोगे, ऐसे लोड अप्लाई करोगे, ठीक है। तो अगर लोड अप्लाई करेगा तो ये ऐसे, मतलब ऐसे ब्लड होके क्रशिंग हो जाएगा। अगर अगर लॉन्ग कॉलम रहेगा तो लॉन्ग कॉलम में क्या होगा, ऐसे बेंड होगा, ऐसे बेंड होके टूट जाएगा। तो यहाँ क्रशिंग हो जाएगा और यहाँ बकलिंग होगा। समझा? हाँ। तो तो ये एक्चुअल ये सिनारियो। अगर तु अगर तुझे याद होगा तो जनरली स्ट्रेस कैसे कैलकुलेट करते हैं? लोड बाय एरिया, राइट। ये लोड बाय एरिया अपन स्ट्रेस कैलकुलेट करें। लेकिन आरसीसी में क्या होगा, आरसीसी का फॉर्मूला, जो अगर आरसीसी का स्ट्रेस मुझे लोड कैलकुलेट करना है, तो मेरे आरसीसी में मेरे मेरे आरसीसी में क्या, अगर रेनफोर्स कंक्रीट स्ट्रक्चर में, अगर तो रेनफोर्स कंक्रीट स्ट्रक्चर डिजाइन कर रहा है, तो रेनफोर्स कंक्रीट स्ट्रक्चर में आरसीसी सब्जेक्ट खत्म हो गया। हम्म, तो उसमें क्या होता है, रेनफोर्स कंक्रीट स्ट्रक्चर्स में अपन कॉलम डिजाइन करते हैं। तो कॉलम डिजाइन करते समय अपन को पता होना चाहिए कॉलम कितना लोड रहेगा, कॉलम कितना लोड लेगा, हाउ मच लोड कॉलम कैन टेक, अपने को वो पता होना चाहिए। तो अगर मेरा मुझे अगर मेरा मेरा बिल्डिंग पर, इफ इन माई बिल्डिंग, इफ 20 किलो न्यूटन load is acting, this is external load. This comes from the different application purpose. If 20 kilonewtons load is coming on my building, and this load should be taken by the columns, okay. So I should know the column capacity. If P is the ultimate load capacity of column, okay, ultimate load capacity of column. So the material which we are using, the ultimate load capacity depends on the material, right? Material which are using, ultimate material which are using, it takes some stress. Materials which we are using takes some stress. So take some stress. So this stress, the material takes some stress. So we'll see. For example, this is the, this is the curve for real stress, right? This is stress and strain. So this is curve for steel. So steel can take, if we are will consider up to this only. In strength of materials, will comes up to yield point, right? So steel can take some amount of stress. Let's consider 2 MPa strength. So this is the load carrying capacity of the steel, right? I mean the steel load carrying capacity, I mean, is the stress carrying capacity of the steel. So similarly, the material which are we use, the steel and the concrete we use in the for manufacturing of the column or for making column, we use steel and so this steel and concrete has the some load carrying capacity. If the steel and load are together has the 30 kilonewton load carrying capacity, so actual external load is 20 kilonewton per. So 20 kilonewton is less than the 30 kilonewton. So I can use the column. If 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 the load carrying capacity of the column is 10 kilonewton, and the actual load is 20 kilonewton, so I can't use because the column gets failure, right? आप समझा? तो इसलिए मुझे मेरा ऑलवेज लोड कैरिंग कैपेसिटी ऑफ द कॉलम शुड बी मोर देन द actual load. So here, for that, in case, because the concrete and the materials have the some defects, so there might be some defects. So If I consider exact strength, then it might failure. So here I take factor of safety. So factor of safety, so I'll reduce the strength of the column. Here the working load or factor of safety we call as working load. If you are reducing the, if you are reducing the actual stress capacity of the column or actual stress capacity of the material, that is working load. And if you are increasing the load, you increasing the load, and based on the increasing load, your building can take 20 kilonewtons, but in future there might be some of your relatives or some other purpose, so you might be using your building some different commercial purpose, that time the load might increase, so you consider that also. So 20 kilonewton I will multiply, generally 1.5 times extra will be taken. So if I take, then it will become 30 kilonewton. So I'll design my building for 30 kilonewton. For example, I'll design my building for 30 kilonewton, but I never use my building that extent. So this is the factor of safety. If you increasing the load, external load, then that factor is called factor of safety. If you are reducing the actual stress of the material, means here you are underestimating the your materials which are you using, the stress of the material, stress capacity of the material which you are using, so you are underestimating. So if you are underestimate, you will use high amount of material, so that in future if there is very bad happen, so you are building able to take the stress, that stress. So that is working load. Understood? So generally for equilibrium, generally we analyzes the column by assuming stable equilibrium, stable equilibrium condition, one condition, and also neutral equilibrium condition, and one more, unstable equilibrium condition. So a Tino condition assumption, generally we assume these two conditions. We assume these two conditions, we'll analyze the columns. So generally what happens, see, this is your column, this is your column, let's say this is your column, okay. So this is your column, and here if you take the cross section, here my column is square, let's consider my column is square, and this is the, say, if load is acting at this point, load is acting at this point, okay, loading acting at this point, it will generate normal stress, right, hello. अगर लोड सेंटर में एक्टिव रहेगा तो क्या स्ट्रेस जनरेट होगा, नॉर्मल स्ट्रेस, क्योंकि जो लोड एक्ट कर रहा है, इट पासेस थ्रू द सेंटर एक्सिस, राइट, ये ये यहाँ से पास होगा, यहाँ लोड एक्ट करेगा, यहाँ लोड एक्ट करेगा, यहाँ से चले जाएगा, right, here the cross section I am showing, this is the plan. So if load is acting here, if load is acting here, it has some eccentricity, right, so the columns might bend. Now the if load is acting here, ye, the column might bend, right. So in this case you consider only normal stress for analyzing the column. In this case you have normal stress plus bending moment. So you should consider two types of stresses here. Understood? So in this case, you should consider two types of the stresses, and in this case, you should consider normal stress only. So if there is some eccentricity, then you should consider normal stress. So I'll I'll tell you one formula, direct formula. Some formulas I'll tell you. So these are the important but very important formulas. So generally, this you can derive this is slenderness ratio. Slenderness ratio is used to, why slenderness ratio is used. Initially, I told long column and short column, right? That long column and short column are classified on the basis of slenderness ratio. Okay, that columns. So based on that, we'll call slender. Based on that, we'll classify the slenderness ratios. So generally, for see if there is the capacity of the column. So if you generally, the strength of the column, the formula is generally calculated. This is the stress, pi square E and lambda square. So this is the general formula which is used for calculating the ultimate load carrying capacity of the column. Because if you are using some material and this material has some stress taking loads, right? For example, if you are using stress, if you are using steel has the capacity to take the load. And for example, how we are finding that? This is the curve which we get, right? Load carrying, to find the how much stress that so for example, there is 250 mps strength is steel is taking. So this is the amount of the stress the steel can take. Similarly, sigma e, if you are making column concrete plus steel, so you want to calculate the stress carrying capacity, the stress, what is the stress that can be taken by the column. For example, if I am using the steel, I am using the steel columns. So if I am using the steel columns, right? If I am using the steel columns, so for steel columns, this is the this is the this is the formula I have, right? So this is the formula I have. For example, I am using steel column. For steel columns, I know the this will be the 250 ampere, right? Because from the test we I know this will be a 250 ampere pi square, and I know the elastic modulus, right? Elastic modulus we can find by the stress strain curve, right? So I know, then I'll get lambda. What is lambda? Lambda is the slenderness ratio, right? So slenderness ratio, and based on this slenderness you'll get the slenderness ratio now. If you solve this equation, you'll get the slenderness ratio. From this slenderness ratio, you can tell how much will be the how much height I can keep, right? How much height I can keep the column, right? Understood? Because slenderness ratio depends on what? Slenderness ratio has the what i- what a slenderness ratio depends on. Slenderness ratio depends on the height of the column. uh, so generally slenderness ratio is calculated by uh, effective length by actual length. So so what is effective length again? Effective length is the, for example, if there is a column, this is the column, this is the column where both ends are hinged. Okay, both are hinged. So this is the effective length in this case. You might be surprised what is the actual meaning of the effective length. Actual meaning of the effective length, the point where the bending moment gets changed, the point of contraflexure we generally call. So generally, this is, if you consider this as the beam, so if the load is acting in horizontal direction, this problem we didn't generally solve, but these are the you can solve. So there might be like this. So if this, here one end is fixed, another end is hinged. So in this case, this will be here to here, here to here, effective length. Because here to here effective length, and this will be the approximate. These values are fixed. Okay, you need not to calculate. Already a lot of experiment has done to calculate these values. How this effective length got? This is by based on the research. Lot of research has been gone to calculate the effective length. If you apply the load, if one end is fixed, another end is hinged. If one end is, both ends are hinged, both ends are hinged, and what is the effective length? So in this case, the effective length will be L. In this case, the effective length will be L by root 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 2. So if both ends are fixed, if both ends are fixed, then the effective length will be L by 2. If one end is fixed, one end is free. One end is free, so then the effective length will be 2L. So you, if you take this 2L and you substitute this thing, and in the slenderness ratio, you'll get how much height you can put the column. So the this is the one type of you can expect. This is the one type of problems you can expect. Okay. For example, I just told you there is there is a cross section, right? This is the cross section of the column. So if load is acting, if the load is acting, if the load is acting somewhere which has E, eccentricity. So this is the eccentricity. Because of this, bending moment generates, right? Bending moment generates, and also normal stress generates. So there is some area you can put. If the load is acting in this area, if the load is acting in this area, there will be no. If the load is acting in this area, there will be no bending moment. Okay, this is generally called middle third zone. Generally we use to all. So in case of if it is square section, or if it is rectangular section, if it is this is the dimension d. If you consider this is the breadth, so generally this so this will be the area. So this column will be generally d by 6. So you can ask me how, sir, this is it. So this has the some derivation formula also, and these are the tested also. These are There is a lot of research went to test whether the these are the theoretical calculated values. So and the testing has been also done to whether that makes sense, the theoretical calculated values make sense. So this is the area. So this is we general called middle third zone. Zone. If the load is acting in this zone, there will be no eccentricity. So in that case, you can just consider normal stress and you can analyze the things. Okay. So these are the few summary of the column. You can if you have any doubt, you can ask me, or we can solve one problem also. But before that, you have any doubt, you can tell me. This is middle third rule. This is the case of uh, for example, this is the in case of that is in case of rectangle. If the column is circular also, right? In circular, the core will be of dimension d by 8. This is in case of circular. If it is hollow column, this is the hollow, where this is the area and this is the hollow. This is hollow part. So in this case, the Emax can be eccentricity. The area, this area can be, Emax can be d square by AD, where d is the small d is the internal diameter. This is the internal diameter. This is the internal diameter. Small d. This is the internal diameter, and from it is external diameter. This is the internal diameter. So what happens if you keep the load within this permissible limit on the section, there will be no eccentricity will be created. Okay. Any other doubt you have? Yeah. What doubt? So see, this is the summary of the. So now if you can watch the lectures, you should able to understand. This is all the summary of the columns. So, or I'll just tell you. So there might I'll explain you some problems. So if I give you, this is the case. This is the case. This is the case. If there is a very big building, I mean buildings like Burj Khalifa, they have very big columns, right? If is the case, in this case, both ends of the columns is hinged, and there will be a two lateral supports will be provided. Okay. What could be the what could be the effective length in this case? You want effective length, right? If you want effective length, because in slenderness ratio, you want to keep your column within the limits. If it is crossing more than some value, slenderness ratio, if it is crossing more than some value, it might be fail in the buckling. So you don't want your column to fail in the buckling, because buckling occurs at very less load. You want your column to fail in crushing, right? Because crushing takes very high load. To occur crushing, you should apply more load. If you want to occur buckling, so if you want to occur buckling in your column, you if you apply less load also, the buckling will occur and ultimately the building gets collapsed. So how buckling occurs? If the columns is very high, the length of the column or the height of the column is very high, in that case buckling. So for that case, you need your column to be short, or what is the permissible limit, the height you can keep, so that your columns is short. So that is we used for that, what we use slenderness ratio. Understood? एक बार मैं जो क्या क्या बताया, आप एक बार समराइज कर सकते हो क्या? लॉन्ग कॉलम शॉर्ट कॉलम, हाँ समझ गया, वेरी गुड. तो इस केस में अगर कॉलम, अगर कॉलम ऐसा होगा तो, ऐसे कॉलम होगा तो उसका, इन दिस केस द इफेक्टिव लेंथ इज L by 2. ओके, दिस इज द L by 2. इन दिस केस द लेंथ इज L by 2. ओके, तो द इफेक्टिव लेंथ क्या आएगा? इफेक्टिव लेंथ इज L by, see, I'll tell you one good case studies. The effective length will be L by 2. Okay, this is the L by 2. If the total length is L, small small l, so the effective length will be L by 2. If one case, if one end is hinge, another end is fixed, and there are two lateral supports are provided. Okay, so in this case also the effective length is L by 2. In this case also the effective length will be L by 2. If one end is hinged, other two ends are, if you keep roller here, so in this case the effective length will be L. Okay, these are the old IES questions. तो स्लेंडरनेस से क्यों यूज करते हैं अपन? स्लेंडरनेस रेशियो, अगर स्लेंडरनेस रेशियो इज 1.105, अगर स्लेंडरनेस रेशियो इज 105, that is short column. Okay, अगर स्लेंडरनेस रेशियो इज greater than 105, that is long column. अगर लॉन्ग, आपको क्या करने का है, ऑलवेज स्लेंडरनेस रेशियो लेस देन 105 रखने का, क्योंकि अपने को चाहिए अपना कॉलम क्रशिंग में फेल हो, क्योंकि क्रशिंग बहुत ज़्यादा लोड पर रखकर होता है. अगर मैं कॉलम बड़ा रख दिया तो कॉलम बकलिंग में फेल हो जाता है. तो बकलिंग में कब फेल हो जाता है? थोड़े आधा स्ट्रेस में भी बकलिंग हो जाता है कॉलम. तो मेरा जैसे मेरा मतलब मेरा बिल्डिंग का पर्पस ही नहीं है. चलो ये हो गया कॉलम. और कुछ डाउट होगा तो बता दे, एक्सप्लेन कर दूंगा, नहीं तो विल क्लोज द सेशन. कुछ डाउट है क्या प्रीवियस सेशंस में? आप क्यों अटेंड नहीं कर रहे? आज बहुत दिन के बाद आज अटेंड किया लगता है मुझे आप. एग्जाम भी आ गए हैं. और प्रीवियस में कुछ डाउट है क्या आपको? प्रीवियस सेशंस में कुछ डाउट्स है क्या? ओके, आप प्रीवियस वो सब देख रहे हो ना लेक्चर्स? ओके फिर एक बार आप नेक्स्ट नेक्स्ट वीक अटेंड करोगे क्या? नेक्स्ट वीक अटेंड करो। हाँ, तो नेक्स्ट वीक में कुछ डाउट्स है तो बता दीजिए कॉलम्स में, तो एक्सप्लेन कर दूंगा वो पार्ट भी। एंड करें क्या सेशन? ओके, थैंक यू शीला चंद्रा।